Welcome to Your Math Explained, where we make math simple and clear. My name is Angela. Up until now, we've worked with trig ratios and right angles and the unit circle. Today, we're going to put these ideas together and solve trig equations. And the way to do that is to follow these 4 steps outlined over here. So step 1, we need to find the reference angle. And then step 2, we're going to use the quadrants to find where the trig ratio has the correct sign, which is your ASTC rule. Step 3, we're going to write the solution as angles in standard position. And then finally, step 4, we're going to determine coterminal angles as additional solutions if it's necessary. Now let's take a look at how to implement these 4 steps using an example. So step 1, we're going to find our reference angle. And we're going to do that by drawing our triangle. So if we have a right angle triangle with our angle theta, and if we have sine of theta is equal to 1 over 2, then that means our opposite side is 1 and our hypotenuse is 2. So that tells us our reference angle theta r is equal to pi over 6 because this is one of our special triangles. Now for step 2, we're going to use the quadrants to find where we have the correct sign for our trig ratio. So we're going to draw our x and y axes, and we're going to label the quadrants with our ASTC rule. So here we can see that sine theta is a positive number. So if it's positive, then that means we're either in quadrant 1 or we're in quadrant 2. So now we're going to go ahead and draw the reference angle in these 2 quadrants. So in quadrant 1, it'll be right over here, and that's going to be our reference angle, pi over 6. And then in quadrant 2, it's going to be right over here, and it'll also have a reference angle of pi over 6. Now step 3, we're going to find our answer, which is the angles in standard position. So in quadrant 1, the reference angle is the angle in standard position. So meaning one of our answers is going to be theta is equal to pi over 6. Now for the angle that's in quadrant 2, we can see that to get the angle in standard position, it's going to be pi minus pi over 6. So that means our second solution is going to be 5 pi over 6. And since our domain for this question is 0 to 2 pi, which is 1 full rotation, we don't have any other additional solutions within this domain. So there's no need for us to find other coterminal angles. For our next example, we're going to follow the same steps. So step 1, that is going to be to find our reference angle. So we're going to draw a triangle, and then we're going to label our angle theta. And here we can see that we have cosine of theta is equal to negative root 3 over 2. But remember, we don't care about the negative sign because we're going to use our quadrant knowledge to find where to actually draw the reference angle. So we're just going to treat this as positive root 3 over 2. So cosine is adjacent over hypotenuse, which means this side is going to be root 3 and this side is going to be 2. So again, this is our 1, 2, root 3 triangle, which is one of our special triangles. So this tells us that the reference angle is going to be equal to pi over 6. So now step 2, we're going to draw our x and y axes, and then we're going to label our quadrants. So this is going to be A, S, T, and C. And now we can see that because cosine theta is a negative number, that is going to be either in quadrant 2 or quadrant 3. So now we can go ahead and draw the reference angle in these 2 quadrants. So we're going to have a triangle over here with the reference angle of pi over 6. And then our other triangle is going to be down here with a reference angle of pi over 6. So now step 3 is us finding the solutions as angles in standard position. So for the first one, that is in quadrant 2, we can see that theta is going to be equal to pi minus the reference angle. So then that ends up being 5 pi over 6. And then for the answer that is in quadrant 3, our theta is equal to pi plus the reference angle. So then that means our angle in standard position is going to be 7 pi over 6. And again, our domain here is from 0 to 2 pi, which is one full rotation. And there are no other coterminal angles that exist within one full rotation. So we have no additional solutions. So one tiny little difference between this example and our first example is that here our reference angle is not one of our final answers. So make sure you follow these steps because they are crucial in determining the correct solutions. For a third example, we're starting with an equation that looks a little bit more complicated. But don't worry, it is not something that a little algebra can't solve. We're going to simplify this by combining like terms. We will move all the terms with tangent x to the left side and all the constant terms to the right side. If we do that, we're going to end up with tangent x is equal to negative 3 over 2. And now we're ready to start with our step 1. We're going to find the reference angle. So we're going to draw a triangle with our angle x. And again, we're going to go ahead and ignore the negative sign. So tangent x is going to be opposite over adjacent. So that means it'll be 3 here and 2 here. So now notice that this is not one of those special triangles, which means we're going to have to resort to a calculator to find our reference angle. So what you're going to do is you're going to go to your calculator and you're going to press the buttons arctan, which is tan inverse, of 3 over 2. So make sure you don't put in the negative sign. And also make sure your calculator is in radians mode because the domain that we're given is in radians. And if you did everything correctly, you should get that the reference angle is roughly 0.983. Now step 2, we're going to draw our reference angle in the quadrants. So here we have our A, S, T, and C. And since our tangent x here is a negative number, that tells us we're either in quadrant 2 or we're in quadrant 4. So now drawing our reference angle in these two quadrants, we get one here. So this is our XR. And then the other one is in quadrant 4, which is down here. And then finally, for step 3, we're going to use this diagram to find our solutions. So the angle that is in quadrant 2 is going to be x is equal to pi minus our reference angle. So that ends up being roughly 2.16. And again, make sure that you use the full value for the reference angle when you put it into your calculator. So don't round your answer until the last step. And then our other answer, which is in quadrant 4, is going to be equal to 2 pi minus our reference angle. And that is roughly 5.30. Now for our final example, we have something where the domain is a little bit different from the previous examples. So let's not worry about that yet. Let's go ahead and continue with our step 1 to 3, and then we will take a look at how to address that in step 4. So our step 1 is to find the reference angle. We start by drawing our triangle. We have our angle x, and since sine x is equal to negative root 2 over 2, ignoring the negative sign tells us that our opposite side is root 2, and then our hypotenuse is equal to 2. So this is that 1, 1, root 2 special triangle, or once we rationalize it, it becomes root 2, 2. But either way, that tells us that our reference angle here is equal to pi over 4. Now step 2, we're going to draw our quadrants. Put in our A, S, T, and C. And then looking at the ratio, we can see that we want to pick quadrants where sine is negative. So that's going to be quadrant 3 and 4. Go ahead and draw the reference angle in these two quadrants. So they're going to look something like this. And then step 3, we're going to find our angles in standard position. So the quadrant 3 angle is going to be x is equal to pi plus pi over 4. So that is going to be 5 pi over 4. The angle that is in quadrant 4 is going to be 2 pi minus pi over 4. So that means that's going to be 7 pi over 4. So these two angles are only the angles within one full rotation, meaning they exist only within the domain 0 to 2 pi. So since our actual domain is negative 2 pi to 2 pi, that means we need to find the solutions within one negative rotation as well. So this tells us that for each of these two answers, we're going to go one full negative rotation. So i.e. we're going to go clockwise one full rotation. So that means our other two solutions are going to be x is equal to 5 pi over 4 minus 2 pi, and x is equal to 7 pi over 4 minus 2 pi. And then simplifying those, we're going to get negative 3 pi over 4 and negative pi over 4. So these would be the two solutions within the domain negative 2 pi to 0. So this would be our step 4, which means in total for this example, we actually have 4 solutions in the domain. And now let's go ahead and do a recap of everything that we covered in this video. So we learned how to solve trig equations by following these 4 steps. Step 1 is to always find the reference angle. And if it doesn't apply, find the axes angles. Step 2, we're going to use our ASTC rule to determine where the trig function is positive or negative. And we're going to go and draw a reference angle in these quadrants. Step 3 is we're going to use that diagram to find our angles in standard position using the reference angles. And finally, step 4 is to use coterminal angles to find additional solutions if the domain includes negatives or it goes above 2 pi. Make sure you always follow these 4 steps as they are the foundation for more advanced trig equations later on. And now it is your turn to give this a try. Can you solve this equation here using the 4 steps we've outlined above? Make sure to leave your answer in the comments below and let us know if you'd like to see more content on solving trig equations in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.